All right, good morning. So your programming test 1 is this Wednesday, so the rule will be the same as before. Please just wait outside the room, and then we'll let you in as soon as we are ready. Please go over lab 1, and also for lab number 2, even though it's not covered, you should really also get starting to complete it. It's also very important, especially it will involve the exceptions for you to practice. So for programming test 1, last Friday, the review session, we decided to release the recording. So please take advantage of that. You can find the links on the e-class announcement. I just announced that last night. So please take a look. I'm pretty sure that will actually help. But your priority will definitely be to really redo the practice test 1 and also redo the lab 1. Set yourself some time constraint, or maybe more than 80 minutes. That's okay, because those tests are a little bit longer than the actual one. Any questions about the course? All right, good. Let's now do a recap, and then we'll continue. So today, we'll do lots of tracing in the second half. In the first half, we still got to cover some basics about regression testing and also about how you can expect from the test cases, etc. But we'll do lots of tracing today to help you understand about the subjects. So last time, we actually finished off the examples about exceptions, especially we talk about whenever you have a loop right here, a while loop, you can use a Boolean variable over here to control the entrance and exit of the loop. Especially the loop itself contains some try and catch block. So I wouldn't dive into details again. You should really review about the different execution flow. Especially, for example, some input which is going to trigger the exception, which is going to cause another iteration of the loop. And the final value that's actually valid is going to cause the exit from the loop. So these are the two important values you should really definitely understand about how the Boolean variable is going to be used and also updated for the flow. All right, and then version number 1. It's much simpler without any loop. So that one there, I'll leave as exercise for you. So these are just some example test cases you can try. And we talk about a bank example here. Nothing very special. We just got 3 methods in the call stack right here. So we kind of figured that out together last time. You just have to remember, so if you got a call like this, you got a withdraw method. And the context object over here is an array indexing expression. We know that accounts over here was declared as account array. So we know that indexing into a particular position is going to give you account. So we know that the callee, in this case, will be from account.withdraw, right? That's how we figure out. So you want to get used to this kind of like a longer chain of method call, or maybe some more sophisticated expression, especially array indexing. That's really the key, okay? Any questions about this particular expression here? That might be something you have to write, maybe in your lab or maybe in the test. All right, and then we spoke about you may have multiple catch blocks associated with a try block. The idea would be you might get multiple lines of method call in the same try block, where each one of the method call may throw some different kinds of exception. And we assume that all the exceptions you create are not related to each other. So it doesn't really matter about the order. You can say, I want to catch this one first, or I can catch this one first. Doesn't really matter the order. You can swap the order of the catch block. But it's very important for you to know, as soon as, for example, let's say this line here, trigger an exception, you know that the rest of the try block will be interrupted, will be bypassed. So you go to the relevant catch block that's going to catch that, which will be this case. So that's the scenario we tried to trace together last time. You should really give a try on the other one. But I happen to trace the other one actually in section G for your fellow students, so you can take advantage. Feel free to refer to the recording in section G. You will see how test case number 2 is actually traced. But if you really get the idea, good for you. Okay. And that was the last example we did for exception, just about the similar idea. So we still have a while loop over here. So we got some Boolean variable, and then that will be used to control the exit and entrance into the loop. And then we talk about if this method call here throws certain exception, you're going to bypass the rest. Otherwise, you're going to proceed to the next line. So this kind of binary execution flow is very important, because today we're going to talk about how you can design a good test for your implementation. That's something we're going to talk about today, right? I'll get there a little bit later. But it's so important for you to know if you have a method call here that may or may not throw some exception. At the runtime, either you proceed to the next line, or you might just need to go to the relevant catch block, either way, right? Either normal or abnormal. All right. And then we talk about the just review the catch will specify principle, right? That's something we said quite a few times. So hopefully you're more comfortable with it. And this will be the running example we're going to use for the JUnit lecture. We're going to use this class a lot today. So let's just recap about the detail quickly. So we have a counter right here. At the runtime, we assume that we can only have 0, 1, 2, or 3. Only these 4 values for the counter. So the minimum is 0, and the maximum is 3. Only 4 possible values. And we're saying that when you're trying to increment, if the value is already 3, you cannot really increment any further. There's going to be something called value too large exception. If you are already in 0 symmetrically, you cannot really decrement any further. In that case, you will expect some value too small exception. All right? So the implementation here about the if condition here is correct. All right? But now, today, we're going to dive into a very important issue here. When you are a software tester, your goal is to really make sure the implementation you're given is actually correct. But what do we really mean, the implementation being correct? That's something we'll see today, right? So here we are lucky. The if condition here was implemented correctly, right? With just the right value. But what if they are not correct? If they are not correct, a good test should really be able to fail on the wrong implementation. A good test should really pass on the good implementation or correct implementation. And a good test should also fail on the incorrect implementation. So we've got to see both scenarios today. Okay. Right, so that's the last page we spoke about last time. Okay, let me just recap again very quickly. So we got 4 different possible values for the counter, 0, 1, 2, and 3. And then we got 4 possible scenarios where we can do, we got 3 possible scenarios where we can do increment from 0 to 1, 1 to 2, and 2 to 3. Symmetrically, we also got 3 scenarios to do decrements. That'll be legal. You can go from 3 to 2, 2 to 1, and also 1 to 0. So that'll be 6 scenarios already. So we said that these 6 scenarios are the scenarios where we do not expect any exception to occur, right? So we say all these ones over here, we do not expect any exception to occur. But if anything that actually occurred, that's kind of exceptional. I mean, if any exception happened, we know that we should fail the test because there's something wrong from the implementation. Now, symmetrically, about these 2 scenarios right here, when I try to increment when the value is already too large, or when I try to decrement when the value is already too small, in these 2 cases, I do expect some exception to occur. If the exception occurs, the test should really pass. If the exception did not occur, then it should really fail, right? So these are also the possible scenario we got to deal with. I'm just hand waving a little bit. I'm going to write something down concretely, and then we're going to see many examples to reinforce this idea. Okay. Overall, any question about the running example we are trying to set up over here? Right? We're going to see lots of scenario today to trace the flow. Okay, at least the basic background. I want to make sure everybody's okay. All right, good. All right, let's now move on. Okay, so I want to start by talking about very quickly some quick syntax, right? This is something you have seen ever since the tutorial for Lab 0, but maybe I didn't really emphasize that, on the writing. So why don't we do that very quickly, just to clarify the terminology as well. Whenever you got a JUnit test class, and then you have a method that comes with the @test tag, right? We're using JUnit 4. But if you're using maybe a newer version, they don't require this test tag anymore. But we're assuming JUnit 4. So that's our assumption. Okay, so we said that this particular test method right here, right, can be test 1, test 2, etc. So this is something in JUnit. We call the test method. So this is the JUnit test method. And think about the test method here is a caller. It's a context where we're trying to make some method call to your implementation. So this is apparently the caller. So who is the callee? Let's identify the callee right away. Okay? Callee is right here. From my class, which is my implementation. Okay? So this is our implementation. Implementation. And then we create the context object O, and then we're calling getValue. So you can think about the getValue here is the method under test. Okay, there's a special name for that. this is the method under test. So each assertion should really test a particular method, right? So it's a method under test. Under test. And of course, we know that it's a callee, right? So that's also straightforward, okay? So we got a caller, we got a callee. Caller is a JUnit test case, JUnit test case. And callee is the implemented method we want to test, whether or not it's correct or not, right? Is correct or incorrect. And let's talk about the assert equals right here, right? We talked about before, the left-hand side, you got two arguments. This argument here and this argument over here. The first argument here is so-called the expected value. That's a convention. Okay, so this is what we expect to see from the implementation. Expected value. And then the right-hand side, which is a method call. And we assume that, of course, getValue here is an accessor call, right? It's going to return something that's not void. So this will be the actual value. So we got something that's expected and something that's actually returned from your implementation. If they match, the pass. If they do not match, the test fail. As easy as that, right? All right, let's now just visualize this quickly, just to see how we can understand about all these different parties over here. So what we have is, let's start with maybe the method under test. The method under test, from the tester point of view, you don't really know the 100% detail about the code detail unless you kind of step into it. So it's more like a black box for us. So the method under test, in this case, it is the getValue method from the counter. Okay, getValue. And each method call should really take some arguments in general. Of course, in this case, we don't really take any arguments. So putting generally, you might take some arguments, some input value for you to do the computation. So I'll put argument here. Arguments. And then it's going to return something. Return value. It's a very simple model, just about being each method being a black box. You give some input, it gives you back some output. What about the test method itself? The test method itself is also like an input and output box as well. Okay, but now the input is going to be a little bit different. So if you think about the JUnits, okay, the green one. So this will be the JUnit test method. JUnit test method. And the name of the method is called test in this case. What will be the input here? The input, first of all, is going to be the expected value. Right? You can see we got the expected value. That's one of them. All right? So the expected value should be one of them. Expected value. And also, the arguments of the method we are trying to test, the method that we are trying to test, and also whatever return value that we get. All these are something that we're going to run that's going to be run behind the scene. We don't have to worry about exactly how to run each method, but we're just going to know the result from here is going to be fed in as input as well. So you can think about this will be one input right here. This will be also one input right here. And this will be another input right here. Okay, so all these are input to the test method. Okay? And then overall, it's going to compare the expected value against the return value. So what's going to be the result from the test method? Conceptually, it's either pass or fail. Okay, pass or fail. So it's either going to pass or it's going to fail. Nowhere in between. Okay, pass or fail. And when we say pass, somehow you can conclude that your implementation is correct. When you fail, that means your implementation is incorrect. It is so important for you to distinguish between testing and also implementing. So these are two different tasks, right? Although sometimes in reality, the implementer and the tester might be the same person, but that's okay, but it's different roles. Okay? So that's why in a team, it's usually recommended the implementer and the tester better be two different persons, so you don't have any bias when you try to test people's code, right? But for now, just for illustration, it's the same person, okay? Guys, any question about the concept over here, right? Hopefully that's rather simple, right? I want to go over the basic stuff a little bit more quickly. I want to spend more time tracing with you. I think that's more important to clarify, okay? Let me do one more thing. Okay, one or two more, okay? Another concept over here, this is on your slide number 11, okay? I'll make a note here. You can just go to slide number 11, you will see this diagram here. You can also see on the lecture side, I also gave you another standalone diagram here. So this just kind of tell you the flow about performing regression testing. This is really not very technical, but it's something very conceptual. You really want to somehow to see if you can apply that to your lab developments, or not too much in the programming test, but maybe especially when you're developing your labs. I would highly recommend you try to incorporate that as much as possible. Let's see the step, okay? So, to start with, we have Java classes to develop, right? You may have multiple classes to develop, go one by one. So we got Java classes to start with, okay? So I'll start with this box over here. So these are the model in the model package, right? In the model package, and could be, maybe I'm developing a counter class, or maybe in your lab number 2, you're developing the vaccine or distribution center, etc., right? You develop one class by one class, okay? Once you have developed something, let's say you want to write some test cases. You might be given some starter, but you also are encouraged to write some test cases yourself as well. So derive here is a very important step over here. But let me just clarify, okay? In this course, we don't really teach you many techniques about deriving test cases based on the implementation. Itself is worth a course, okay? So for those of you who might be interested, you can take as an elective for CS major. So it's EECS2030B, I believe. It's a software engineering testing course. They'll just show you different techniques about deriving test cases, like black box, data flow-based test cases, developments, etc. Right? So I wouldn't go there in detail for this course, right? But when you say derive the test cases, you want to be as complete as possible. That's a principle. As complete as possible with respect to the problem description. So in the lab, we try to give you some starter tests just to give you enough test cases so you can get some good starting point. But when we actually grade your programming test, let's say in a different scenario, we can also have some extra test cases to make sure any missing scenario that's not covered in the starter test, we can also test them on your code. So you got to make sure whenever you're developing your Java classes, you should really think about what's really the problem description being given. I want to program as general as possible. I don't want to program just specific to the starter value I'm given, right? You want to be more general. Okay, problem description. Okay, that's so important. All right, let's say you derive some test cases, and then we got JUnit test cases. Okay, so this will be another box right here. Okay, so that'll be the JUnit test cases. So now, the question is, should you actually finish developing all the classes and then you start writing test cases? That's not the way to go. Right? So there's something called incremental developments. What you really want to avoid is try to finish everything you're supposed to implement and then write test cases. That's not the way to go. You want to start testing your code as soon as your code is testable. Okay? That's what people recommend. I'll write it down. Okay? So this part over here, we want to follow as much as we can incremental developments. Incremental developments. Okay, incremental developments. Incremental, okay? One at a time. One class at a time, or even one method at a time. Before you actually go to the next method, you should really test the current method thoroughly, or as much as you can, before you go to the next method. Okay? So the idea here is you want to start testing the code as soon as it becomes testable. Okay, so now, testable in the sense that maybe I just finished implementing the constructor. That's okay. I can already test about my constructor, maybe initializing the attributes in a certain way, right? Testable, that means some logical units is completed. Some logical units is completed. You know, for example, maybe the constructor, or maybe some accessor, etc., right? You can simply finish implementing one method and test it right away, right? That's something you can do. All right, let's say I have implemented something already. I also got some test cases testing, what I've implemented so far. So what I should do is I'm going to run my JUnit test class as Java application or JUnit test case. And the JUnit test framework I set up in my Eclipse is going to give me either green or red, right? That's something you're also very used to. So if I got red, that simply means I got at least one test that actually failed due to a mismatch. Remember, we just spoke about in the earlier page, a test will fail if the expected value and the actual value from your implementation do not match. If there's at least one test fail, that means there's at least one mismatch you have to address. Okay? At least one test failed due to a mismatch between expected and actual value. Okay. And what should you do? Well, in this case, you should really go back to your code and use breakpoint and debugger to really find out what the errors are. Right? In that case, you will go back to your implementation code, and then you want to use the breakpoint and debugger. And debugger. So sometimes you may have failed multiple test cases. In that case, fix one test case at a time. Sometimes maybe after fixing a particular error, you can pass all the test cases. It's possible. But I'm just saying, fixing one test case at a time. Okay? And if you actually got a green bar right here, okay? Let's be careful about here, right? Getting a green bar doesn't really mean you're now happy forever. Definitely not, right? So let's clarify that concept as well, which is pretty straightforward. Okay? So let's say all the tests passed. All the tests passed. Of course, depending on how many test cases you may have only one test case, you may have 10, you may have 100, depends, right? I just say all tests that's available here. When all the test cases pass, you can somehow declare your software is correct. However, be careful, when I say correct, it's relative. The software you have implemented is correct. I put in quote. Because it's really with respect to the test that's run. All right? And then the more test, the more and diverse tests you have, the better. The better. Okay, so I think here it is important to emphasize about diverse. You should really focus on quality as opposed to quantity. Having 1,000 test cases sounds good, but if all those 1,000 test cases are focusing on only one aspect of your software, what about other aspects? They are untested, right? So you want to be as diverse as possible. Okay? So diverse over here is very important. But how do you make sure you derive all the test cases that somehow diverse? Of course, you have to somehow look at the problem description to figure out what are the scenarios I should really test. You want to test each one of them. Okay. Okay, so that's about, okay, why is that called regression testing? I think I kind of borrow from the like a real life scenario, right? I believe it comes from reading. Maybe back in our high school, elementary school, when you're reading a passage, right? So let's say you got many lines of text for you to read. Regression goes like, if I read line by line, when I'm here, I forgot about what I have just read. I go back to it and try to read what I have read again. And then I go on, and then I go to here. I forgot about what I have read. I just go back to where I was and then start reading again. I keep repeating what I have read. Regression, right? Regression in the context of reading is a bad thing. But in software development, regression is a good thing. That means to keep running the test cases you are actually have already built out, okay? Regression. Okay, one more remark to say, okay? So this flow here is very general framework, very general flow, very simple to really understand, but to really exercise it in the lab development, it's actually not easy. You want to really force yourself to really have that habit, okay? You want to make sure you rerun all the test cases every time you have made a small change to your code. So every time maybe, so let's say before some change, you want to make sure the following, okay? So think about it, this one here. Let's just use a flow diagram, state diagram. Let's say here, I have made some changes. Made some changes. Maybe I fix some method, or maybe I try to extend something, okay? Whatever changes you made. And then, let's say before the test, you got n tests passed. You want to make sure after changes, the same n tests still pass. None of them should really fail. You don't really want to make, you don't really want your changes to really inject any error. That's the bottom line. If they have injected any error, you should really go back to your code and fix them. All right. And here, the same and test remain passing. That's what you want to really keep as often as possible, right? If any changes you have injected, any changes you have introduced to your project actually have injected some error, you should really fix those errors first before you go on. Okay, that's a principle. All right, guys, any questions? Okay, okay. One or two more small things, and then we can go on to talk about something very interesting. Okay, we are very intellectual. We're gonna do something could be slightly confusing, but I'll try to go over that slowly. Okay. All right, so very quickly, just to mention, so in the slides, from slide number 12 all the way to slide number 25, so these are just like a tutorial slide just about how you can use JUnit test cases. That's something we pretty much cover in lab number 0, part 1 mainly. So I would say those slides here, just skim through them just to see if there's any missing information you don't really know about, but otherwise, everything should be covered already. So about later on in the written test 1, for example, after the reading week, make sure you also study those slides. Nothing new there, really. Everything has been covered. But we can focus on something that's new today. There's just one page I would like to talk about. Okay. So this one here comes from your slide number 16 and 19. I'll make a reference here. So slide 16 right here, and also slide 19, right? These two slides. Okay. Part of the self-study. Okay. Let's look at this one here. So this is a very important definition about when should a test fail, all right? The result of running a JUnit test is considered failing if either some assertion failed. That's obvious, right? Maybe you have some assert true, assert equals, assert false, etc., right? If any one of them fail, then the test will fail automatically. And there is one assertion here called fail. That's something you may not have seen. Right? This is something we're going to see a lot today. Okay? First of all, let's understand this fail assertion. Okay? The assertion, the way to write it is, the way to call that assertion is simply say fail with no arguments like that. That's how you write it in Java. What does this assertion do? It failed always, always, unconditionally. This will cause the test to fail unconditionally and immediately. Unconditionally and immediately. You can also think about assertion failure is but like an exception happening. If the assertion failure happened, everything should be disrupted. and terminate it abnormally right away. Okay, similar. All right, we'll see lots of occasion about using the fail assertion. We're going to see that. Okay, we'll get there. Right, so either some assertion failure occur or if some unexpected exception. When I say unexpected, not really something you'll try and catch, because once you catch the exception is basically already handled. So there's nothing wrong with it. So it could be null pointer exception, could be array index out of bound exception, right? So these are the two we actually spoke about when we talk about OOP review. So if either of these exceptions occur, it can also cause the test to fail. Okay? Just remember, simple definition. And a test will succeed if neither assertion failure nor unexpected exception occur, right? Simple definition, okay? So that's about slide number 16. So please take a look just to make sure you're familiar with the definition for test case success or failure, okay? And when you first create like a test case in JUnit, right? You got all the relevant imports, and then this will be some test case that's actually generated for you by default, right? And you can see the default implementation for a test is simply say, I simply fail something. I can add some string arguments if I want to. So this test over here is always going to fail unconditionally, immediately. So it's simply a test over there just to remind you that you should really implement something useful for this test. Hopefully you will pass at some point, okay? So a very simple question. What would be the easiest way to make this test pass? What would be the easiest way? According to the definition that we set above in slide number 16, this test over here fail always. How can I make it pass? Comment out the fail. That's exactly right. Okay, that's the easy one. However, that's exactly the point I want to make as well. Easiest way is simply say like that. This will comment it out, so this test will just pass because it does nothing. After commenting out, the fail assertion, the test passes trivially. Trivially in the sense that no failure and also no exception occur. Pass trivially means no exception and also no assertion failure occur. This one tells you, when somebody tells you that I gave 1,000 test cases to my implementation, should you be so confident about the fact that they run 1,000 test cases? Not necessarily in general, because I can easily duplicate this test method here 1,000 times. I can get a test report, green bar, at 1,000 test cases passing. But is individual test doing something useful? Not really. So the quantity of your test cases is not the way to really focus. You want to focus more on what exactly is being tested, right? Because by the very definition, in order for a test to really pass, you just got to make sure nothing happened. But beyond that, you want to make sure you really test something useful, right? So that this simple question here just tells you that point, right? You don't really want to trick yourself by having a feeling so good about having so many test cases passing. You want to look at exactly what the test is testing, right? Okay, let me now, so we can now talk about the series of examples, okay? So let me just clarify some concept right now, and then we're going to follow the same principle for all the examples, okay? We're going to do lots of tracing, okay? We're going to focus on the design of a test. Design of a, you can say JUnit test, of a JUnit test. How exactly do we design a test? And just don't forget, it boils down into a test is really trying to assess if some implementation is correct. So the way to do that is call that method and to see the actual value matches the expected value. If they match, pass. If they do not, if they do not match, fail. Just remember the very definition about what a test is. You want to assess whether or not the method under test is correct. Okay? So now, it's all about expectation. So there are two kinds of expectation. Let's now put them explicit. Okay? I'll put expectation 1 here. Expectation. Sometimes the expectation might be certain exception might occur. Okay? Certain exception should occur. Certain exception occurs. And one example would be, let's say I'm trying to increment when the counter value is its maximum. If the counter value is already at its maximum, I should not be allowed to really increment, right? In that case, I should really expect some exception to be occur. Value too large exception. Okay? So expectation is about certain exception might occur. That's one category. Okay? So we're going to divide into two scenarios. So when the test is trying to test for that particular implementation given, we are expecting the exception to occur. Okay? There are two scenarios. If that kind of exception is thrown by the implementation versus that kind of exception is not thrown. Is not thrown. Think about these two are the different scenarios you might encounter the test, right? The test should be able to deal with both. Okay? Well, you can see that if the exception is really thrown, in that case, it will match the expectation. In that way, the test should really pass. If somehow the implementation you're testing did not throw that exception as expected, in that way, it should really fail the test. Not thrown, which means it's not as expected. In that way, you're going to fail the test. Let me say it again. The test has some expectation. I'm expecting the correct behavior to be certain exceptions should really occur. If the exception really occur, then I will pass the implementation. If the exception I'm expecting was not thrown, in that way I should really fail. The implementation was not correct. Okay, so a test should be able to tell whether or not an implementation is correct or not. That's something we'll see. All right. All right. What about the expectation is something the opposite? Okay. Let's talk about another scenario. It could be that the expectation is we do not expect any exception to occur. Certain exception does not occur. Does not occur. So this is our expectation. Okay? So let's see one example. What will be the example? So here, example could be, I try to increment when the counter value is just 0. Just minimum. In that case, I should be able to increment from 0 to 1 without seeing any exception. So I do not expect to see any exception. So now let's think about what's going to happen here. We're still going to enumerate about the two possible outcomes from the given implementation under test. If the implementation either give me that exception, which I don't expect, or it might give me, or it may not give me the exception. Right? So let me write it down. So that kind of exception is thrown versus that kind of exception is not thrown. Right? So now let's talk about these two cases. Because in this case, the expectation is I do not expect the exception to be thrown. In that case, if the exception is not really thrown by the method under test, that should pass. So this one here should be pass. However, if the exception is thrown unexpectedly, I should really fail. One thing that's so important for you, you can see, let's see the failing case is thrown right here. So this is not expected. Let's say for implementation, if the implementation simply do not throw that particular exception, and also it's thrown, that particular exception is thrown, you can see the different outcome. It's either fail, let me put it this way. I want you to look at these two. This will be easier. Look at this one here, and also this one here. Okay, if you look at the orange boxes, this one here and this one here, both cases are when the implementation will throw some particular exception, right? However, in this case, it is considered as a pass. But in this case, it's considered as a fail. Why is that? Because the expectation is different. When I'm expecting some exception to be occurring, then it's really occurring. Then it should be passing. If I'm not expecting any exception to occur, but it actually occur, then I will fail. So this principle here about 4 different combinations are something we're going to see in the tracing example. I want to talk about all of them at one go first. Okay? 2 dimensions. First dimension is about expectation, whether or not we're expecting some exception. And dimension number 2 is about what exactly is happening in the implementation at runtime. Okay? And then we want to see if the expectation is met or not. All right, any question about this page here? It's more like an abstract view, just to summarize about the pattern. But we're going to see actual code. Okay? Okay, if you're good, why don't we take a short break, and then we'll start going over examples right after the break. Okay? All right, so let's now go over examples. Okay? I got basically 3 sets of examples together. Each one of them has 2 scenarios to consider, so 6 of them in total. But let's go one by one. Okay? Let's focus on the first one. The first one, once you get it through, the other 2 are very similar. Okay? Let's talk about the following. Okay? First of all, I want you to just take a look at this test case over here. Okay? Spend just 1 minute taking a look at that. I want you to especially pay attention to this line here. This line here, if you remember, that method there specifies the value too large exception, if you recall. Okay? Just remember that. At least you know what the structure looks like. Okay, one more moment, and then we'll start talking about it. Okay, let's now take a look at this method here. So the green one and the red one, they are really identical, just duplicates. But I want to talk about the 2 scenarios. Okay? First of all, we know that this increment method here, C.increments, specifies it may throw. It may throw the value too large exception. Similarly, in the duplicate here, the C.increments over here may throw value too large exception. May throw the value too large exception, right? And remember what we said maybe last time or the 2 classes before. We talk about different execution flow, right? When the exception occur or not occur. So we got 2 possible scenarios, okay? Let's say this. In the case where value too large exception occur from here, in that case, should we go to the next line? We shouldn't, right? We should go to the relevant catch block. Agree? In the case where, let's say, in this case, let's say the value too large exception occur. In that case, we're going to bypass the rest of the try block. And then we're going to go directly to the catch block that will actually catch the exception. In that case, we're going, okay, and then we're going to execute this line here. And then it's going to fail the test. So this one tells you that the test failed. Okay, number 1. Number 2, if the exception did not occur, the value too large exception did not occur. In that way, we are actually going to go on to the next line and then check to see whether the counter value has become 1. And then we reach the end of the try block without any exception, and then we're going to bypass the catch block. Right? We bypass the catch block, and then we reach the end of the test right here. And so far, no unexpected exception or no assertion failure has occurred. In that way, we pass the test. I'm basically just going through the 2 possible execution flow of the same test. So this particular JUnit test is capable of checking if a particular implementation is correct. But what's the expectation here? So let's now go over the expectation, right, accordingly. The expectation is when we try to call this increment method right here, increment method, when the counter value is equal to 0. Because when we first initialize the counter, the value is simply just 0. In that case, we should not trigger any exception, right? So that means the value too large exception should not be expected. Not expected. Not expected simply means when we say the increment is implemented correctly, that means it does not throw the value too large exception, right? And then when we say it's implemented incorrectly, I'll show to you one example. That means it will throw that exception. The value too large exception, okay? Expectation goes like this. We do not expect the exception to occur. We do not expect it to occur, and it did not occur. Agree? Let's just go over some example quickly, and then I'll come back here. That might be a little bit easier. Okay, I'll just say come back here. I'll come back to summarize. Let's just see some flow. Okay, let's see here. So the same test right here. And then I'm showing to you the implementation. Okay, and we assume that this is the correct implementation. Okay, correct. And let me remind you very quickly the expectation. The expectation is the value too large exception does not occur. Okay, just remember this expectation. Okay, let's see what's going to happen here. Okay, let's now just label the different lines, 1, 2, 3, 4, etc. as before. Okay, let's try that. So if I say counter, I'm going to create a counter. Okay, oh, sorry. Create a counter, so that'll be label 1. And then I know that after creating this counter here, counter that value will just be the minimum, as we said last time. So counter that value will just be 0. Okay, so this is good. And then we go for 2. We check this assertion. we know that the minimum value is actually 0. And 0 and 0 here match. So this assertion is good. There's no assertion failure. So far we are fine. Okay? And then we go into the try block. Number 3. And we know that this particular increment here may or may not throw the exception. It may. May throw the value too large exception. But in this case, we do not expect the exception to occur. We do not. Otherwise, the implementation will be considered incorrect. Okay? Let's see what's going to happen here. So we're going to step into the increments. Okay? So we're going to go into the increment right here. So at the moment, C dot value, just remind you, at the moment, C dot value is actually equal to 0. Right? And then we try to compare this Boolean expression. So 0 equals counter the maximum. And remember, the maximum is 3. 0 equals 3 will be false. So we bypass. And then we simply increment the value from 0 to 1. So that's correct implementation. We didn't throw that exception, right? We are not supposed to. Okay? So after this, you can think about this one here. Did not throw the value too large exception as expected. Okay, this is so important, as expected. So in that way, we can actually go on to the next line. So we'll go to number 4, and we try to see the C dot get value. Now it should be 1, right, as we said earlier. So it's matching the expected value. So this assertion here also passed without failing. So now we are able to reach to the end of the try block over here without any assertion failure and also without any unexpected exception. Always good. So we can bypass the catch. All right, and then we reach the end of the test, and then we say that it's going to be a pass. So what we have achieved in this case is when we are given a correct version of the increments, we will be able to exercise the execution flow like 1, 2, 3, 4, and then bypass the catch block, and we are able to get to the pass. So that's a passing the implementation. Okay, so the test passed because the given implementation is correct. All right, so this scenario is kind of easy to see. Right? You might be thinking, oh, the implementation must be always correct. Not necessarily. When you are the tester, you should never assume what you're given. What you're given might be incorrect. Let's see one example. So this scenario here is good, but let's see another one. What if the implementation is incorrect? Okay. What I will do is I'm just going to make a change over here. So let's say rather than equals over here, I'm going to say less than. Okay? That's the only change I'm making. I'm creating some implementation that's incorrect. All right? Incorrect implementation should really cause the same test case over here to fail because it's going to go for another execution flow. That's a critical point. Okay? So this one here is incorrect implementation. And if you remind yourself about the expectation we have, the expectation is the value too large exception should not occur, right? The value too large exception should not occur. Okay, let's see how things are going to go. Again, we're going to trace. So what we do is we're going to start from creating the counter, and after initializations, counter the value will be 0. That one will be the same. Okay? And then the initial assertion, the counter value is simply just 0. That's okay, right? We don't expect anything to go wrong right here. So 0 matches 0. And then we'll go to the first line in the try block, C dot increments. And then we'll step into it, right? And we also know that the C dot increment here may or may not throw that exception in general. May throw the value too large exception. So let's now step into the increments. So we go here. At this point, C dot value is equal to 0. Just remind ourselves, just after initialization. And then we're going to compare this. The value itself is 0. The maximum is 3. 0 less than 3. True. That means we're going to throw that exception unexpectedly. So that means after number 3, and then we got number 4 here, and then we got number 5, right? So you can think about this is where the wrong implementation will do. So the value too large exception is thrown unexpectedly. All right, let's see what's going to happen here. So after number 5, we should go to number 6, right? Because this line here has thrown that value too large exception. So you can make a note here. So the value too large exception is thrown. That means we're going to bypass the rest of the try block. And we're going to go to the relevant catch block that's going to catch the exception, which will be right here. And then we're going to go into the fail, which is the first line of the catch block. So that's going to be number 6. It's going to fail. Remember, the fail here is going to fail unconditionally. Okay? So this one here is going to fail the test case. Okay, so this will be the outcome for this particular test. So if you recall from the previous case, the same test, when we are passed on correct implementation, the test will actually pass. But now when we are passed on incorrect implementation right here, the test will fail. So that shows that our test is a good test. A good test should not really always pass. You don't want that, right? It should really pass on the correct implementation. It should also fail on the incorrect implementation. Okay, I'll write it down. So the same test fails because the given implementation is incorrect. All right, let me recap very quickly, and I'll take some questions. So this first set of example here is actually very crucial because the second set and third set will follow a very similar thing. Just the expectation might be a little bit different. Okay, so let's recap very quickly. So for this example here, we do not expect the exception to occur because what we're doing is we are just creating some counter and then call increment from 0 to 1. Of course, we don't expect any exception to be occurring. So in the case of correct implementation, when we execute this line here, the value too large exception is not going to occur. And that one is as expected. In that way, we don't really go to the catch block and execute a fail. So the test will actually pass. On the other hand, when we are given some implementation that's incorrect, in that way, it will actually throw the value too large exception unexpectedly. In that way, from here, if you actually got the exception thrown, it got interrupted and go to the catch block, it's going to fail. All right? So when you study for this example here, just remember what the expectation is. You do not expect to see the exception. Okay? Any question here? Daniel, go ahead.
There's a string that you provide
in the fail.
Sorry.
Oh, sorry, you mean the string here?
No, in the
You mean increment?
yeah, does the string that you provide here, is it supposed to be the same as the one that's in catch block?
You mean the exception, right? Yes, exactly. So we know that if you look at the header of the increment method, in the background, we say that the increment specifies the value too large exception. So that's why the try block over here, this exception may or may not occur. And we know that in this particular setup, increments when the value is actually 0 should not trigger the exception. So if the exception actually occurs, we know that it's a failure. If that did not occur, we know it's a success. Okay, let's now move on. Let's go to a second example. In the first example here, we do not expect to see the exception. In the second example, we do expect to see the exception. And now we want to think about how can we somehow redesign the test to suit that purpose. All right, that's important. Let's take a look. Okay. All right, this one here. So guys, again, please take 1 minute here. This test here looks almost identical to the first one, almost. Except you want to look at where the fail assertion goes. That's my hint to you. Okay. Let me give you one hint, if you don't mind. You can see somehow the fail assertion goes right after the method call, as opposed to going to the catch block. Right? That's in the first version, right? In the first test. But now in the second test, we kind of change the place of the fail assertion. Okay. All right, let's now think about what's going to happen here. Okay. In this case, we are trying to do decrements. So we initialize the counter, the value will be 0, and then we try to decrement. So we want to go from 0 to -1. That should be disallowed. That means we are expecting some exception to occur. So the expectation is completely different, right? So now let's think about the different scenario. We know that the decrement here may throw the value to small exception. And the decrement here, the identical code, may throw the value to small exception. We know that, right? Let's think about what if the exception got thrown or not thrown. These are two different scenarios at the runtime. Okay? So now, if we are able to, let's say if it is thrown. If it is, let's say if the value to small exception is thrown. If the value to small exception is thrown. How would the flow go? Apparently, we shouldn't really go to the next one because the exception is going to interrupt the flow. And we're going to go to the catch block that will catch the exception, which will catch the value to small exception. And here, inside the body of the catch, we simply do nothing. Do nothing simply means no assertion failure and also no unexpected exception. Just do nothing, right? In that way, it's a pass. So this means the value to small exception is thrown as expected, and we pass. Let's see the other possible scenario at the runtime. Let's say the exception did not occur. If the value to small exception is not thrown, which is unexpected. In that way, we're going to go to the next line. And then it's going to fail right away. Okay? And we're going to bypass the catch block. So this will fail the test. Because the expected value to small exception is not thrown. So the setup for the second example here is completely the opposite to the first example, right? So I think we should have enough time to at least finish the second one. So before Wednesday, make sure you go over the 1 and 2, right? They got completely opposite setup, okay? I'll go to the expected behavior a little bit later, but let's now take a look at the example code right away to do some tracing, okay? So now, let's take a look at this. So that's the test, and then what we're trying to do is we initialize a counter. And then we try to call decrements. So we know that the expectation is this decrement here should really trigger the value to small exception. Right? We know that. Okay? So we know that over here, the expectation is the value to small exception occur. That's our expectation, which is the opposite to example 1. All right, let's now take a look to see what's going to happen. The implementation we are given is assumed to be correct. Okay, you can see that we just use equal, equal. That's a correct implementation. Okay, let's now trace the code. Number 1, the counter value after initialization will be, 0. And then we try to assert equals, the initial value should just be minimum. Okay, it's the same as before. So this one will also pass. We go to the very first line of the try block over here, called decrements. We know that this C dot decrement here may or may not throw that value to small exception, but we do expect to see that exception to occur at this point. But let's see. Okay, so step into the decrements. So go in here, and then we'll go for number 4. So value right now, C dot value right now is 0, and then counter minimum is actually 0. They match, equal, right? So that means we're going to go for number 5 right here. We're going to throw that as expected. So this value to small exception is expected. And bypass the else part. So we know that from C dot decrement here, value to small exception thrown as expected. So where should we go? Well, so number 6 should be we bypass the rest of the try block. So we get away from failing. And then we go to the catch block that's going to catch the value to small exception. And then we go to right here. Think about number 6 right here. Just do nothing. Do nothing, that means no assertion failure and also no unexpected exception. So this will pass the test. So the test passes because the given implementation is correct. And more precisely, it is correct in the sense that it throws the value to small exception as expected. Any question about this? Okay. Let's see another scenario. Let's say the same test. What if we give a wrong implementation? Okay. So let's say this implementation here is a correct one, but I'm going to modify just one part. Let's say this one here, rather than equal, I'm going to say less than right here. That's the only change I made. So now I basically made this implementation here incorrect. So this one here is incorrect. Implementation. Right, let's now try to trace the code, right? The same test. If it was a good test, then it should really fail on this incorrect implementation. Okay. Again, the expectation is we do expect to see the exception. The expectation is the value to small exception should occur. Okay, let's see. So now we do 1 here, and then after initialization, C the value will be 0, minimum. And then we check assert equals the same, right? This one here, just minimum. That one's okay. And we go to the very first line for the try block. And then we go for C the increments right here. At this point, the expectation is we expect to see the exception. If the exception did not occur, that means we should fail the test, right? Let's see. So now let's go into the test right here, okay? So at this point, C the value as before, just 0, okay? And then we're going to run the incorrect implementation. So it's going to be number 4, okay? So 0 less than, minimum value is 0. 0 less than 0, false. So we do not actually throw the exception, which is not good because we are supposed to. So what's going to do is it's going to go for number 5. It's going to decrement the value from 0 to -1. You can see it's very bad, right? So that's why we said this is an incorrect implementation. What should be the consequence of running a test on an incorrect implementation? It should fail, all right? Let's now complete it. So we know that this one here, this line here, the value to small exception not thrown. So what we do is we just go to the next line, number 6, and we're going to fail that right away and bypass the catch because no exception has been thrown, right? So it's going to fail the test. So the test failed because the given implementation is incorrect. Implementation is incorrect. And let's be more precise over here. Incorrect in the sense that it did not throw that value to small exception. Okay? The value to small exception not thrown when decrementing counter with value 0. Okay? All right, guys, any question about this? Good? It's not too bad. You're just going to be very clear whenever you're setting up a test, know about what's really the expectation. Does the expectation somehow cover you are expecting some exception to occur or not to occur? And then you will set a test accordingly. Okay? Okay, I think we got time just to see the third possibility, third test. Okay? So example 1, we saw where the exception was not expected. Example 2, the exception was expected. Example 3, what about some part we do expect to see the exception, but somehow we do not expect to see it? It's also possible, right? And we're just trying to get more and more challenging for us. Let's see this one here. Okay? Let's now just take a look at this test. Okay, this one I'll give you a little bit of guidance, and then I want you to also spend just 1 minute looking at the test. Okay, this will be our third example. So here we basically have 2 try and catch block. So the very first try and catch block is here. We got the second try and catch block over here. The first try and catch block, we try to increment 1, 2, and 3. And in the second try and catch block, we try to increment further by another 1. Okay? So try to look at these 2 try and catch blocks and think about, do these 2 try and catch blocks have the same expectation when they called increments? Okay, you have some answer, right? Just give me 1 moment. Okay, I'll just let you fellows think about it, right? That's a key, really. Whenever you want to decide whether a test is really appropriate, think about expectation when you call the method. Okay. I'll give you guys just 1 moment to think about, and then I'm going to highlight some stuff. Okay. All right, go ahead. What's your insight?
They do not have the same expectation.
I agree. Okay. So let's say, how about this? Let's say the orange try and catch and also the pink try and catch. Well, how are they different?
So the orange one is not expecting an exception to be thrown in the first place. The pink one is expecting an exception to be thrown.
Okay. Can you just justify very briefly why?
In the orange one, the try block does not have any failing clause. So it expects to increment and then just pass through as if nothing happened. But in the pink one, when increment is called, exception is we're expecting to catch. Otherwise, we are going to fail. And that's why it's in the try. The fail is in the try block.
Pretty good. But let me just try to also explain from a slightly different angle. Okay, but that's good. Okay, this one here, all good. We are supposed to get 0 from here, and then from the first increment, we're supposed to go from 0 to 1. The second one, we're going to go from 1 to 2, and the third one go from 2 to 3. All these 3 increments, we are not supposed to see any value too large exception. Number 1, and then at this point, before the second catch block, counter value should be equal to 3, right? Now, it's already reached its maximum. So when we do 1 more increment, we should expect to see the value too large exception, right? So we got different expectation. Let me write this down, and then some insight, and then we're done for today, okay? You can think about here, we got 2 phases. You can think about this is phase number 1, and this is phase number 2, okay? Phase number 1, phase number 2, okay? So this will be phase number 1, where the value too large exception is not expected. And this will be phase number 2, where the value too large exception is expected. And accordingly, you can see where the fail assertion is placed. In one case, it's put under the catch block. The other one is put right after the method call. They're put in different places. All right? So before Wednesday, I would like you to do the following. Please review the first 2 examples, make sure you really understand. And then in this 3rd example here, really get yourself convinced. We got 2 phases over here, which got the opposite expectation. And on Wednesday, we're going to finish tracing the version 3, and then we solve some challenging questions together. And then we're done with the lecture. And then we'll go to equals method. All right? Thank you so much. And then I'll see you on Wednesday.